Welcome back to our class notes on Unit 1. This is page 7 of our unit. So as we've been saying, make sure you print out, if you can, this handout, and this would be the 7th page in Unit 1. We've been talking about the properties of matter. We mentioned extensive properties are those properties that matter how much is there. If you change how much is there, the extensive property will change. Intensive properties do not matter how much is there. So if you change how much is there, it's going to be the same. So if you have a gold coin, it would have the same properties as a bar of gold, which might be able to be made into 100 coins. Same intensive properties. They would have the gold bar has the same color as the gold pennies. It would have the same melting point. It would have the same boiling point. It would have the same density. It would have the same hardness. It would have the same ability to work it. They're both the pennies very malleable. The gold bar is very malleable. We went on in our last video to talk about the differences between physical properties and chemical properties. Physical properties are things you can observe without changing the substance. You don't need other chemicals present, other substances present to see that property. That's unlike chemical properties, which relates to the ability of a substance to undergo changes that transform it into other substances. In other words, how well it chemically reacts, producing a new compound. We talked about types of chemical properties. We talked about types of physical properties, both qualitative and quantitative. We said physical changes involve changes that are impacting on a substance, but when you're done, you have the same stuff. Ice cube melting to liquid water, you have water. Liquid water heated up till it begins to boil or go from a liquid to a gas. It's still water. It's just water vapor. Physical change, that would be a change in the state of matter in this case. Chemical properties, however, when something undergoes a chemical change, you end up with a new product. You end up with something that has entirely different chemical properties. Chemical change is a process where one or more substances are converted into different substances with new chemical identity. When we're talking about a chemical identity, we mean it is a new substance. You would need a different formula or symbol to represent it, or collection of symbols to represent it. Chemical changes occur through chemical reactions. That's a result. Chemical reactions result in chemical changes. Reactants are what you start with. Products are what you form. They are the result of the reaction. In chemical reactions, chemical bonds holding the reactants together must be broken. So in a chemical reaction, if you have a compound and that compound has different elements bonded to each other, you have to break those chemical bonds, ending up with the elements that went into those. When you break chemical bonds, you have things that are now going to be together with something different if a chemical reaction is occurring. To represent a chemical reaction, you use a chemical equation. A chemical equation is a shorthand way of expressing what happens in a chemical reaction. Here we have the element carbon, and it is being burned in the presence of oxygen. So when you burn something that has carbon in it, the oxygen will actually join with the carbon to make carbon dioxide. The C and the O2 are our reactants. The CO2 is our product. The O's started off with the O's, and when they were finished, they were now with the C's. Carbon burns in the presence of oxygen very well. CO2 does not burn very well. In fact, CO2 can put fires out. CO2 is often in fire extinguishers. It is the product of burning something. Oxygen is great to breathe. It keeps you alive. CO2, if you breathe it, it does not keep you alive. It can kill you. CO2 is what you exhale. It's what your body's trying to get rid of. Here we have hydrogen gas reacting with oxygen gas to produce water. Hydrogen burns very, very well. That's what happened when the Hindenburg caught fire and burned. It burned in the presence of oxygen. The Hindenburg was filled with hydrogen gas. Hydrogen gas is a very light gas, and it allowed the Hindenburg to float. But when you're finished, you make water. If you drop a match in hydrogen, the hydrogen will explode. If you drop a match in water, it goes out. If you put a match in oxygen, it would merely burn much, much faster. So notice that the properties have changed. Hydrogen burns, oxygen helps things burn, water helps put things out that are burning. Properties change. Chemical properties change when we form the new substances. The arrow here in this chemical equation means yields or produces. The positive sign, the plus sign, is not a positive sign. The plus sign means those are the substances you're putting together. In a chemical change, the amount of matter does not change. Notice we have one carbon here and we have one carbon going out. There's no subscript after it. Here we have two oxygens going in, two oxygens coming out. Whatever goes into the reaction must come out. Here we have two H2s, or we have four H's. Water has two H's on there, and we have two water molecules. 2 times 2 is 4. Here I have two oxygens. This 2 also goes with the oxygen right there. So whatever goes into the reaction must come out of the reaction. That's called the law of conservation of matter or mass. In a chemical equation, what goes in must come out. There are symbols that are frequently used in chemical equations. We already mentioned the arrow sign points at what you make or produce. If you write an AQ, if you see an AQ written after something in a chemical equation, it means you must dissolve it in water. Water is sometimes called aqua. Aqua is a term that relates to water. So AQ after something means you have to put it in water. If you see the symbol delta H written above the arrow in a reaction, or on either side of the reaction, it means that there's a change in heat. It means heat will either be given off or taken in during the chemical reaction. If you see an arrow going both ways, where we're used to just seeing an arrow going one way, an arrow going both ways means, if we had an arrow going back, it means whatever you make can turn around and fall apart into what you started with. So if there was an arrow going back this way, it means hydrogen and oxygen would join to form H2O, but the H2Os could fall apart later to release the H2 and the O2s. That is a reaction that goes both ways, an equilibrium reaction. If you see the word catalyst above an arrow, or the symbol PD, an element symbol such as palladium or CD, cadmium, if they write an element above the arrow, it means that that element is actually not taking, or it can even be a compound. If you see a symbol or a collection of symbols or the word catalyst above the arrow, it means you need something to help that reaction occur. The reason they put it above the arrow is it is actually not doing something on its own. It's just helping the reaction to happen. Itself is not participating in the reaction. If you see an arrow pointing down after a symbol or a collection of symbols, which we call a formula, it means that the substance will precipitate out of the solution. In other words, you have two things put together and you form a solid that will not stay dissolved. If you see an arrow up written after a formula or symbol in a reaction, here we might have an arrow up. Here we might have an arrow up. Arrow up means that what you produce is a gas. When you burn hydrogen in the presence of oxygen, it's at a high temperature and it'll form a gas. If you see the letter S after something in parentheses, it means it's a solid. L after something in parentheses means that it's a liquid. G after something in parentheses means it is a gas. If you see the word temperature or abbreviation for temperature, TEMP, or you see an actual temperature written above the arrow, it means a certain temperature is needed for that reaction to happen. So if you see a temperature written above the arrow, it means you have to have it at a certain temperature for it to happen. If you see the word electricity or a lightning bolt above the arrow, it means you need electricity for the chemical equation to happen. So these are some symbols that you will frequently see in a chemical equation. Chemical equations represent what is happening in a chemical reaction. And when we're looking at whether something is changing chemically. If it does, you would use a chemical equation to show what happened, what you made. But in either case, when a chemical reaction is happening, the properties change. The properties of the reactants will be different than the properties of the substance you form, which we call your product. We're actually going to stop the video right here. Our next video, we will get to the third page, but this is just a good opportunity to stop before we change topics. Thank you for listening.